Welcome to Shelby and Katie. They're here from San Diego, and I'm really excited to hear about their adventures at Intuit. So take it away.
Awesome. Hi, everyone. Our title for our talk is What the F of P is Kotlin, a mixture of functional programming and Kotlin together. So we want to hear how is everyone doing today? How has the 2 days been? Full of Kotlin, exciting, yeah?
A lot of big problems.
Yeah, pumped. It's been great for us. We love walking around and talking about Kotlin all day. So just a little bit more about us. I'm Katie Levy.
And I'm Shelby.
And we both work at Intuit in San Diego. Intuit's a financial software company creating TurboTax, QuickBooks, ProConnect, Mint. So specifically, I worked on the Android application for TurboTax, and then now, more recently, I'm on back-end services for TurboTax since March.
And I work on an internal tools team at Intuit, so we build products to help all of our external products be released with the highest quality possible.
So today's presentation will be successful if your life is changed by Kotlin, if it's not already. You know, some of you already love Kotlin, but for those of you on the fence, your life will be changed and you'll love it forever, as well as functional programming. So we're also going to teach you some key techniques to influence change, and we're going to walk you through the lens of us teaching functional programming in Kotlin to Intuit, a 9,000 employee company that's existed for over 30 years, and how you could introduce a new technology to your company as well. So first, this is a timeline of some big dates for Kotlin. It was first unveiled in 2011 by JetBrains. Then it was open sourced in 2012. It became the first stable release in 2016, and 2017 was a super big year. Google announced the official support for Kotlin on Android, which was really exciting. And then 2018 is when Shelby and I started to get involved in the language. That's when we first learned about it, and we sort of taught ourselves different features, started programming it in our own, and then we started teaching other people about it too. And then 2019, now Kotlin is used by a lot of Intuit products in the Android apps, in some backend services, and then also in some AWS Lambdas. So what is functional programming? There's a lot of ways to describe functional programming, but some of the ways we found Kotlin was really great at teaching was breaking up larger functions into smaller functions, treating your code like mathematical equations, multi-threaded solutions, which is really helpful for Android. What else? So for functional programming, you have the same input giving you the same output. So like Shelby was saying, you have more mathematical equations rather than shared mutated state.
And today we're really going to break down functional programming for you, so it doesn't have to be this large, daunting thing. And we'll break it down into little actionable things you can start to do, and we'll show you how to do that through Kotlin.
So these are the 8 key techniques that we're going to walk you through today, and how we specifically used it at Intuit, at our teams, and then larger at the whole company. So the first one is you want to find your passion. You want to find something you're really excited about, something you could talk about for hours on end. And for us, that was Kotlin. Kotlin really took advantage of the main pitfalls of Java and built on top of them to solve key issues in the industry. We're going to walk through some of them, but it's more concise, it's more safe with kernel safety, it's interoperable with Java, so you can have an application with both Java and Kotlin, and it's tool-friendly. Intelligent Android Studio are great IDEs to learn the language and write the language in them. So after you figure out what you're passionate about, you're going to want to share that passion with other people, like your team. So socializing the idea and seeing what people think of it is the next technique that we use to help introduce Kotlin into it. So what was my experience like? I said I was on an internal tools team, and this is actually a really great place to try out new technology, play around, and it's a really good space for learning. So what we did as a first proof of concept
I did a feature I was going to complete in Java in Kotlin to show my team that I could do it in the same amount of time. And then I wanted to bring the entire team along. So we converted all of our Java data classes to Kotlin data classes. We'll explain why later. This is a great place to start. But it got everyone coding in Kotlin from the beginning. We also created learning resources, so each member of the team could be empowered to be an expert at one part of the language. So if someone ran into a problem, they would document it and kind of teach the other team about it, so we could all be learning together.
Yeah, it's crazy because my experience was totally different. Shelby was on a backend services team, and her team was really excited to learn the language. I was on an Android team at the time, which you would think would be easier to adapt on that team. But the engineers on the team had been using Java for years. They were comfortable with it. They were more hesitant on changing. They're kind of like, why do we even need this new language? We already can do all this in Java. So I had to kind of persuade them even more and convince them why Kotlin was so great to use and why it would make their lives easier. So I gave different presentations to the team on the key features that I loved and how I thought it was easier and funner to write in Kotlin than in Java. And then we also would do some group coding where we would convert some Java files to Kotlin so we could learn together, discuss the different features in a team. And then we also sort of sat down and realized the team still didn't have the confidence to write quality code for our customers, which were whoever was using the Android app for TurboTax. We wanted to make sure there were no issues, so we did a group training course. I really sat down with the team. I found an online Udemy course that was like 30 hours long, found time on everyone's schedule to make sure we all blocked it off and went through the course together. And we're on the same page on we need to prioritize the time to learn it, and then everyone's going to be on the same page, have the same amount of knowledge. So it was exciting getting that foundational knowledge. And then you would think by then everything would be great, everyone would love it, but there was still some hesitancy. One of the engineers was like, yeah, I'm excited, I'm going to write my first PR in Kotlin, it's going to be great. It was also under a time crunch, so we had to get it done the next day, so he wrote it in Kotlin, and we had the PR ready, and I went through, added some comments on things that he could do better. Nothing blocking, but just some enhancements. And then I sent it to Shelby, like, hey, can you review this PR, like, add some more comments, and then I sent it to a few more people just to see, like, he could learn from the PR comments. And it was overwhelming. It was just a lot for him. He saw all these different things that he was doing wrong. They weren't necessarily wrong, they could just have been optimized. And it sort of like shut him down, and he was like, I'm just going to change it all to Java. I can't, I'm not going to do it in Kotlin. So it was a really big learning experience for us to understand you have to do things in small steps, and you don't want to overwhelm people that are learning, especially he was the tech lead, so he was used to knowing everything, and it put him in a position where he was the one that wasn't knowing everything. So it was a good learning opportunity for both sides. He learned a lot about the Kotlin language, and after that, he really took it positively afterwards and was like, okay, yeah, these are things I learned, these are ways I can improve, let's keep using Kotlin. And then it was a learning experience for us. We can't overwhelm people with all of these great things because we're so excited about so many parts of Kotlin.
And it's easy to get overwhelmed because there's a lot built on top of Java with Kotlin. But what we found is the molded ones here were what we started with to just try and make a big impact and convince people right away. So we're going to go into some of the details on how they work. You'll know probably a general idea, but this is the way that we explained it to our team when they didn't know any Kotlin. So the first one that we were really passionate about, and we thought it was a great way to share what Kotlin's all about, was null safety, which most of you probably know about, but how many people in this room have gotten a null pointer exception? Yeah. So we all know that Kotlin does a great job at fixing this problem that Java has, but explaining that to other people who aren't sure why they should be using Kotlin, who are already Java developers, is a really great way to introduce the language. This on the left is what we typically saw in a lot of our Java services. So we had nested if statements, a lot of mutation, a lot of service calls, and then at the end, if anything was null, we are returning null. So on the right, you'll see the Kotlin code, and it just looks a lot more fluent. And just comparing this for people when you're teaching about Kotlin is really helpful to show them you can still do the same thing when you're trying to interact with Java, but it just looks a lot better.
We've socialized the idea, sharing some of our favorite features with our teammates, and now we have to create a proof of concept. This is a way for the team members to really understand how this makes their lives easier, how they can type Kotlin and everything will be so much faster and easier. So one of the things we did for a proof of concept is a data class. So this is a common Java data class. On the left, you have a Pojo with getters, setters. If you make a typo, then you're going to have a bug. There's just more code to read, more code to write. But with Kotlin data classes, you can write it all in one line of code, and you have all that functionality already built into the language. Now, we have those little proof of concepts as just easy ways for people to understand this is really why I need to use language. And sort of socialize the ideas, come up with these are the features that we really like. You have to create a plan with the team. You have to sit down and really understand what do we want to use Kotlin for and why, what timeline. So I sat down with my team and we did the group training. Like I said, we sort of understood we need more foundational knowledge, did the online training course together, and then we had different goals that we came up together. We want to first do test classes. That's a really easy way with low risk to convert Java to Kotlin and build up confidence on the team. And then we moved on to the data classes, like we were saying in the proof of concept. You can easily change a Java and Pojo into a data class in Kotlin, and you get all the built-in functionality and so much less lines of code. And then we also had to measure the impact. We really want to see what impact is Kotlin making for our team specifically, and how is it making our lives easier. So we measured, at the time I was on the Android team, we measured the number of crashes. So without null pointer exceptions, we didn't have crashes. One of the features I worked on, it had around 60% crash rate. It was pretty bad, and we got that down to 0% because there were no null pointer exceptions. So that was a huge win for the team. And those small data points are really helpful to convince other people.
So we define success, and as Katie said, data is really important. Engineers like to be convinced by data. So we got these points from the Kotlin website that rough estimates indicate approximately a 40% cut in the number of lines of code from Java. If that doesn't convince you, more concise code takes less time to write and more importantly, less time to read. So this increases your productivity. And when we explained that to teams that they weren't going to have to write all this boilerplate code, it really helped them get on board with Kotlin right away. Brings us to our next point. Showing specific ways that we remove boilerplate code with Kotlin is what we did next to persuade engineers. So we have, most of you know these things if you're familiar with Kotlin, but they stood out to us as really easy ways to teach eliminating boilerplate code. So first we have type inference, really helpful. We don't have to define string in the variable a at the top. We also have single expression functions, so that's what we talked about with functional programming. Your code can look more like mathematical equations. We have string interpolation, where you can call a function or use a variable inside of a string. We also don't use the new keyword, and there's no semicolons.
These are all great data points. Another one to really drive it home is these are some of the tech companies that are using Kotlin today in production. They're some of the top tech companies in the world. It really shows how the industry is moving towards Kotlin and it's becoming a more popular language. It was also rated on the Stack Overflow 2019 survey, the 4th most loved language. So that's a really key data point on engineers loving the language and then companies also adopting the language.
So we have a plan and we're trying to convince people. We have a bunch of data, but there's still some false information going around. And people might have these conceptions of what Kotlin is if they haven't really learned it yet. And so it's really important to deconstruct those myths and share the correct information with everyone. We did this by writing a formal technical white paper. And this was a document that we wrote inside of Intuit just to formalize our thoughts, to learn how to write a white paper, and to get down all of the deconstructions of the myths that we had while converting our Java code to Kotlin. We wanted to prove that we could increase developer productivity and decrease defects in production. And we got a lot of really great feedback internally, and it really helped specific teams get on board with using Kotlin. So we made an external version of this white paper and got a lot of feedback from helping other companies introduce Kotlin there. So you can scan the QR code if you want to read it. It's online.
So one of the myths that we deconstructed is around Java interoperability. Try saying that 10 times fast, it's really hard. So a lot of people think that if you write a Kotlin application, it has to be only in Kotlin. However, that's not the case. You can have Java interoperability with Kotlin. That means that Kotlin code you write is just decompiled down into Java bytecode, and then you add the Kotlin standard library in. You just include that in your Gradle file or your POM file if you're using Maven. And then you have Java that can call Kotlin classes. Kotlin classes can call Java classes. You can subtype from the two languages. It's really cool. You can mix them together. And this really allows you to build on top of your existing application. For my Android app that I worked on, we already had a huge app, and we didn't want to just completely start over by using Kotlin. So we were able to use what we already had and slowly add in Kotlin files and migrate over time. And it really allows you to do the migration process at the speed that you want while you're producing new features for the business.
Once we knew that Kotlin and Java worked really well together, we also needed to know that we would have all the same tooling support that we already had in Java. At a big company, it's really important to have great tooling and have standardized tooling across teams because with 9,000 employees, a lot of different tools, we need to have the same support. When introducing a new language, it's a much easier argument by showing this. So we included this in the white paper just to say we have the same build automation tools, code coverage tools, testing tools, CI/CD pipeline, and then also IDE support just to help developer productivity.
Another myth is that Kotlin is just for Android applications. But we can tell you it's for other applications as well. It's any application that runs on the JVM, Android, there's Kotlin.js, so JavaScript, Kotlin native, so you can build an iOS application in Kotlin, and you can use any of these IDEs. This has been something big for us as the company. A lot of engineers in the company think it's only for the Android applications, and we're really pushing for server-side Kotlin applications. So it's really good to note that it's not only for Android.
Another myth that we kind of had to deconstruct was that it was hard to learn, or that if you're a Java developer, there's going to be all new syntax you need to learn. But it was actually really easy for me to pick up as a new engineer. So on my team, as I mentioned, I did a feature that I was going to do in Java already, but I did it in Kotlin to prove I could do it in the same amount of time. So I added it to our Java Spring Boot app, into our Maven POM as a dependency, and then developed the feature and got it in the same amount of time. So this kind of proved to us that anyone could do it if you already knew Java, or even if you were a new engineer who knew other languages like Go, Swift. There's a lot of similarities there too. So immutability and functional. So we're talking about this because it's important to have immutability in your code, and it doesn't mean that your whole entire project needs to be functional. And Kotlin does a great way of teaching these things and having immutability by default in the language. So some examples of how Kotlin encourages functional programming is expressions, not statements. So in Java, we have a lot of things like if statements, switch statements, and in Kotlin, you can make those things expressions. So you can assign them to a variable, you can return right away. In this specific example, we have a function foo that takes in a param, and when the param is 1, which is an integer, we're going to return the string 1, and 2, we're going to return the string 2, and then else, we're going to return we don't know. But the cool thing here is that since I defined the return type as string, if I change any of those logic blocks to a different type, we'll have a compilation error instead of a runtime error. So if you start using expressions instead of statements, you don't mutate variables along the way, and we can verify by the compiler that every logic check is returning the same type. This eliminates a lot of just developer errors and encourages the best style of coding. We can also have val defined to have immutable variables, so we can't reassign it. That's a compilation error also. And then var for immutable variables if you still need it. In addition, we have collections defined, so list of is going to be an immutable list. And then if you want to create a mutable list, you still can, but the developer actually has to type mutable list of. So it's a very conscious behavior of writing out mutable, so it starts to have developers thinking about what they're typing more.
So we also have Lambda support in Kotlin and in Java 8 as well. So functions are first-class citizens. That means that a function can be stored as a variable, it can be returned from a function, or it can be an argument to a function. And Kotlin builds on top of this even more by adding certain functions on the Kotlin collections. You have your Kotlin collections built on top of the Java collections. And these Kotlin collections have certain functions added on, like map, filter, fold, flat map, which are functions we love to use. They're very functional, and they allow you to chain your operations in a very simple manner and with immutability.
This is an example of a function in Java that is mutating, or in this case we're not mutating, but we have a list of cities, it's a list of strings, and then we created a new list, great cities. We're using a for loop to iterate through, and then if it equals Boston, we're going to add that list to the great cities list. So we're going to jump into the code more and show you how we would convert this to Kotlin.
So, I need a guess on how long do you think it would take Shelby to write this same code in Kotlin in an imperative manner?
60 seconds.
2 minutes.
60 seconds?
12 seconds.
12 seconds? Okay, we'll see who wins the two of you. So I need you guys' help to count. I'm going to say ready, set, go, and she's going to start typing and we're going to start counting. Ready, set, go. 1, 2, 3. Whoa! Easy. So we wanted to show that IntelliJ and Android Studio has a lot of tools built into the IDE to help you convert Java code to Kotlin. So you don't have to go and sit there and rewrite all of your Java code into Kotlin. You can either paste it into a Kotlin file like I did, which automatically converted it, or when you're in a Java file, you can click code and then convert Java file to Kotlin file to convert the whole file. So it's really important to understand what tools you have because you don't want to waste a lot of time manually doing something, and this is a great way for you to kind of play around if you're new to Kotlin and learn and see what it looks like in Java compared to Kotlin, and then continue to make it better. So how many lines of code do you think it will take Shelby to write this Kotlin code in a functional manner?
Including everything, or?
Everything.
Everything.
Some guesses.
But not
This
empty
one's
line,
not a
not
trick,
empty
I'm
line.
going to type this time.
She's gonna, it's how many lines of code?
3 lines in the body.
3,
In the body.
3, 1. Said 5. Okay, let's see who wins.
Including the curls.
So she's typing out, returning a list of strings. and using list of to create a immutable list. If you want to create a mutable one, it can be mutable list of, and adding Boston, San Diego, Seattle, and then calling filter on that list, which will keep only the values that match whatever she puts inside, where the city matches Boston. Okay. So we can actually make this even better, and we can use our tools inside of IntelliJ to make it better. So right now we're defining the return type, and we have this block body with the keyword return. So if I hover over the return keyword and click Option Enter, it's going to give me an option to convert this to an expression body. And then once I do that, it will highlight the return type. So that's indicating to me that I don't need it and I can delete it. So now we've actually made this even shorter, but what else can we do? So we have city defined here as a variable. You'll notice I don't have the type or string there, but I could. But also if I click Option Enter on city, it'll give me some more options. And one of them is to replace the explicit parameter city with it. So in Kotlin, we have this awesome it keyword where we can use in simple cases like this, and that will just be each item in the list that we're sending in. So we can make this one line. Yeah. So this is a good example of first class functions later to support. It's an easy way to start out using functional programming by using just map or filter to start out with before you get into some of the crazier functional programming things. So we're going to go into a couple of them. This is map. On the left you see what it would look like in Java. So Java 8 you can actually use Java streams to do map, but then you need to collect it at the end. In Kotlin it's just so much easier. You have the map function already on the list collection. So filter is very similar. We have .stream and in the beginning and then .collect on the end in Java, but then in Kotlin we can do the same and call filter directly and use that it keyword. And then once we started using those at first, just map and filter, and then we started getting more comfortable with functional programming, seeing the common patterns of for loops and ifs inside the for loops and converting them, and then we got into some of the other cool functions like flat map. So flat map will take multiple maps, a map of maps, or a list of lists, and iterate through them. So in Java you can see how you do it with flat map with collection streams, and then you can do map on that to add 5 to each of the maps inside the map, and then collect it to a list. However, in Kotlin it's a lot more concise. You have your 2 lists inside of a list, and then you flat map over the list to add 5 to each list. And this is really cool because it shows Kotlin inline operator too. So if you notice, the 5 is actually being added to the whole list. So once we've gotten there, we have some functional programming. You might also get some hesitancy, but you can't stop. You have to push through the haters, and can't stop, won't stop, keep on going. So we got to a point where we had teached our team, and that's all we were really envisioning on doing at the time. We were focused on the team, how can we make our team better, how can we improve the tech, and then things sort of just snowballed and it became something bigger and it kind of got a life of its own, and we started teaching the whole company about Kotlin. We created a learning community where we meet once a week at work for an hour during lunch, and we'll go through different presentations on Kotlin from different people, how people are using it on their team, how we're using it, different features that people like or have just learned about. And then we'll do some live coding together, converting some Java code to Kotlin code, and adding some PRs onto different projects, which is really fun. And then we'll do some code reviews too to just see how we can make the Kotlin code even better. And also we've gone through different chapters in Kotlin in action just to figure out what are the best practices of Kotlin and how can we use them from going from Java to Kotlin perspective. So while we were in the learning community, we heard a lot about what each people were working on their own teams, either Kotlin or non-Kotlin projects.
And so what we started to do is promote open contribution and open source inside Intuit so that we gave people an opportunity to learn the language or learn a new tech stack when they were on a different team by contributing to a project on my team. So it's a great opportunity to learn when someone doesn't necessarily have the opportunity to get code reviews by different people, and then also if they're new to the language. We tag all of our work with help wanted or open contribution tags so that people will know within Intuit, okay, this is a good first issue for me to get started on if I've never programmed in the language. We also get a lot of work done, so those features and stuff that we tag with those help wanted tags are things we actually want to get done but maybe can't fit in that quarter, and then it's a great learning opportunity for someone else while also getting a ton of work done. We've been really involved in open contribution within Intuit and open source outside of Intuit. We just had a Hacktoberfest. I don't know if anyone participated in Hacktoberfest, but it's basically just the month of October where everyone really promotes open contribution. And we had a lot of fun doing it, so if you haven't contributed to an open source project and you're trying to learn something new, if you go in, look at issues, or add some unit tests, something like that, that's a great place to get started.
At that point, we had taught some new engineers how to use Kotlin at Intuit, and some Java engineers how to use Kotlin at Intuit, and then we got even bigger, and we connected with a larger community. So we went beyond Intuit, and we got connected on Twitter and Slack, met some people around the world that are using Kotlin, learned from their presentations, learned from their projects, and then we were able to show some of our projects as well. So I was able to open source this library called Truffle Shuffle. It's an Android UI component library, so it has little cards that shuffle around, and it's dynamic, so it's really easy. You can just add one line of code to add a new card rather than creating a whole layout and changing the whole layout for how many cards you have. So I'd encourage everyone to look at it. It's written fully in Kotlin and using functional programming. So that's something we were able to share out with the community as well as understand things that people are working on. So attending and submitting to conferences has also been really helpful to us. That's why we're here today. But we've been learning from attending conferences since the beginning. We went to Google I/O in 2018 where we got to meet Andre, the lead language designer of Kotlin. And this was a great experience because we just got to ask about his advice on converting Java code to Kotlin and introducing this language to a large company. But if we hadn't gone out there and saw what other companies were doing with the language and gone to that conference, we wouldn't have had that opportunity to meet him and learn from him. Also, the Talking Kotlin podcast is hosted by Hadi from JetBrains, who I met at KotlinConf last year. And after I met him and started talking with him, I got to be a guest on the podcast, which was a really great experience. And again, wouldn't have had that if I didn't go and see what was out there in the community. And then after being on that, it really helped us relate to other people who reached out to us who were going through similar things at their own companies and learn from the struggles they had to try and work together and continue building the community outside of Intuit. So one specific project that's open source that we connected with outside of Intuit was Arrow. So how many people have heard of Arrow before? Cool. How many people use it in their development? Okay, awesome. So once my team felt comfortable using Kotlin, because we didn't want to introduce too much at the same time, we started to introduce Arrow to have more options of functional types in Kotlin. So one of the first types we started with was either. So an either type has a left and a right, and you can define the type of the left and the right. Typically, the right holds a successful value, and the left holds an error value. So in this case here, we have val right with the left of the either defined as a string and the right defined as an int. So if we want to say either.right, we can send in a 5, and then if we want to send in an error message, we can do either.left, and then put something went wrong. This was the first type that we introduced to our project.
you don't have to go crazy and add everything from arrow right away when you add it to your project, but going slowly and teaching your team about it step by step is really good. So we'll show you why either really helps improve your code. So we talked about map and flat map, but with an either type, when you're using those, it only operates on the success case. So we have right.flatmap, and that's only going to operate on the right side of the either. And then if we call left.flatmap and either.right, it's still going to return the right side.
All right, let's look at an example of how we can take advantage of this either type. So this is some code that parses a string into an integer, and then it calculates the reciprocal, and then it converts the reciprocal into a string. So we have our parse function. It can throw a number format exception if the string is not a number. And then we have the reciprocal function that can throw an illegal argument exception if the number is 0, because you can't take the reciprocal of 0. And then we have stringify at the end that just converts it to a string. So if we look at this parse function that just parses a string to an int, we want to instead return the either type with either number format exception as the left or an int as the right. And we can change the code so that if s matches the regex of an integer, we return either.right of that integer. And then if it's not, then we return an either.left of number format exception, whatever error message we want to return. So we need some help from you guys on figuring out what this code will produce. So if we call parse on the string, not a number, what are we going to get back? Yeah. An either. And what inside of the either? Yeah, awesome. So we have here the either type of left, since we can't parse it into an integer, and then the number format exception is inside of the either, and it has the error message not a number. So how about the next one? If we parse 2, what are we going to get back?
Right to?
Yeah, we got an either of type right with the value of 2 inside. So we have our success case of a right and then our error case of a left.
So now we want to talk about more using flatmap and map to compose all of our functions together. So we have the function at the bottom, magic, and we're calling parse first, which is on the previous slide. And then we're flat mapping, calling reciprocal, and then mapping for stringify. So these ones are a bit trickier, but let's try them out. So what if we had magic with a 0 sent in? Anyone know what it'd be?
So what the code to step through the logic, if we take in a 0, we first are going to try to parse it to an integer, and then once we parse it to an integer, take the reciprocal of it. We can't take the reciprocal of 0. And then if it's not 0, then we're going to stringify it.
So for this one, we would have a left of a legal argument exception, cannot take reciprocal of 0. So now that we've seen that one, does anyone know what the answer would be if we sent in 1 to the function magic?
Right, 1 is a string.
Yeah. Thanks.
What about magic with not a number sent in?
What was the number format exception?
Close. Oh, yeah, number 4, yeah.
Left.
Yeah, so in this case, we have all of our error cases in the left, either left type, and then all the success cases in the right using flatmap. So here we have sort of how you would use this function. So magic is what we were calling to do all those operations, to parse a string into an integer, take the reciprocal of it, and then return back the string. That's all in magic. So in the end, we're either going to get for x an either.left or an either.right with the reciprocal of 2 or an error case. And then we can take x and use the when to go through and see what our error cases are. So if it's a number format exception, we can return back it's not a number. If it's an illegal argument exception, we can say we can't take the reciprocal of 0. And then otherwise we can say it's an unknown error on the either.left type. And then if it's an either.right, we know it was a success value, and we can say we got the reciprocal, success, and return that back as our value.
So we wanted to show you what this would look like converting either exceptions or returning integers to returning an either type after calling a service. This is a function call services that we just made where we try to call a service, we check if the status is something, and then if it is a success, which is defined as the status being a 200, then we will continue on and call the second service. All along, we're mutating the variable status, and then even if it's an exception, we're just going to log the error and return a different integer. So we saw this a lot in our code, and what was challenging about this is throughout the code, we wouldn't really know what was a success and what was a failure. We know here with the first service that a 200 status is a success, but with the second service, it could be a 201 or a 200. And all throughout your code, you're guessing and checking all the time. Is this a success by seeing the status, and is it not, and you're not really sure? So one way you can improve this is by using the either type with the string as the left and integer as the right. We use Kotlin when expressions to say if it's a 200 or 201, wrap the status in an either.right. So instead of the status here, you might have the response object or something more meaningful to the rest of the code. But we just wanted to show you that now the success and error is encapsulated in the type. So you never have to guess if it's a success or if it's an error. We also have something similar as what Katie was saying in the other example we showed, but when we have a when expression and we say is either.right, it actually smart casts to that type. So when we say is either.left and then use the string interpolation to see response.a, we'll be able to put what's inside that either.left in the response.
As you can see, these are some of the key benefits that we took away from using arrow data types like either. So we put the status checks at the lowest layer of the code. We don't throw exceptions anymore. We return back error types. And then we also avoid mutation. This is all very, it wraps in with functional programming. So we have a few resources for you. Our Medium article and white paper, you can scan that QR code. We also were on a Kotlin webinar, which featured some other great engineers at Intuit sharing other places in production that we have Kotlin for server-side and Android. And then the Kotlin in action and Kotlin codes exercises we put, because if anyone on your team or yourself are learning Kotlin, that's where we got started. It's really short exercises that help you learn different features. And we're going to be speaking next at KotlinConf, so we'd love to hear your feedback on this talk or any feedback from you introducing Kotlin to your company. So feel free to reach out to us on Twitter or comment on our white paper and we can respond there. Now we've walked you through the 8 key techniques that we use to influence change at a 9,000 employee company that's been around for over 30 years. And you can really first find your passion, socialize the idea, create a proof of concept, create a plan with your team, persuade with data, deconstruct the myths and preconceived ideas, can't stop, won't stop, keep getting through the haters, and then connect with the larger community. And we really want to let you know it only takes 2 people to start a movement.
Questions? Yes.
Go first with that. When would you prefer either over rolling your own series class?
So that's a good question. I would say, for me, on the projects that I work on, either was really helpful for simple cases when I needed the same response object for a success and error case. So that might be unique or more rare for my project that I work on, but we have used sealed classes and either, and I found that either has been easier to teach than sealed classes. So that's just another tidbit. You can use both of them, but people have picked up the concept of either faster, but I think you could use them both.
But either is a sealed class.
Yeah.
Think about
Yeah,
it.
you could create your own sealed class specific for your project, but it is nice having something that's in a library, it has other documentation, it has other examples and other projects. That's like a key advantage to using something that is in a library.
Is there somewhere I can learn more about sealed classes?
Yeah, so actually, everyone should watch Patrick's talk from Kotlin Cup last year. He spoke about sealed classes and he's really passionate about them, so you should definitely check that out. Yeah.
This plan. So I looked at Arrow and then immediately ran away because I got very scared. Have you guys used any of the other stuff in there?
Yeah, so on my team, when we first started just throwing around either and try and different data types, and then we had a new engineer, a staff engineer join my team who was very familiar with functional programming, and he was really passionate about using some of the other things like async and binding, and what's really important there is that when you're trying to introduce new technology, to make sure you're bringing everyone along. So what we had him do is write comments actually in the code explaining how it was working when he first did it. It was helpful for the code reviews and also helpful when someone else is trying to debug the code and figure it out. But we're relatively new to Arrow, so we haven't experimented that much.
Other questions? Okay, great. You guys are awesome. Thanks so much for coming.
Thanks.